Hello and a warm welcome back. Today on the bench we've got an unknown device, and it's the sort of thing that one is trawling along or whatever you call it on eBay, and you see an interesting looking thing. It's got valves in it and whatever and what have you, and you put a bid on it and it arrives in the post, but you're not quite sure what it does, but you think it's some sort of amplifier. So we need to do some detective work to try and find out what it does and how to get it working. This came through Ian, who I've mentioned before on the channel, and he was asked me to look at a few amplifiers. This is from his brother. So where do you start with something like this? If you buy something off eBay and you sort of done some image searches and all the rest of it, but you can't really find out much about it. Well, for a start, you can get a good idea from the controls. You can get a good idea from the controls. For instance, over here on this selector here, we've got auxiliary, radio, tape, LP and 78. So that dates it backwards in time. We've also got some weird controls like stereo mon and channel earthing. Volume, treble, bass, so we know it's a preamplifier. But apart from that, we don't really know. So what I always do is to take the thing apart. I start by taking a thing apart, taking something like this apart, and then hopefully that will give us some more clues. You can tell by the components the sort of date. I mean, there's no integrated circuits in here, but we can see from the resistors, the capacitors for instance, that this probably what, 1960s, early 70s. So let's just go with that sort of date at the moment. The use of the big wafer switches also dates it, and the capacitors, we could probably get a date code off there, and we're pretty certain that this is a stereo preamplifier because it's got 4 valves. And if we look here, we've got quite a few different EF86s. That one's a Mazda, that one's a Pinnacle. Pinnacle was a sort of rebranding company. They just used to buy loads of valves from all over the world, mainly from Philips, and then rebadge them and put the Pinnacle brand on. So right, we've got 4 EF86s. One thing I have noticed though is that we've got screened sort of valve holders, but they're missing. These particular capacitors these particular capacitors are called mica molds, and they're notorious for not being, you know, they don't date well. Looking at the underside, it's really well laid out. Whoever made this, so the first thing we're trying to sort out basically, is it a kit? Because there are a lot of kits in those sort of times where you would get like the chassis and everything, you'd have to put it together. Whoever made this has done it exceedingly well. I can't fault the workmanship. It is absolutely top notch. It is brilliant. Everything is really nicely laid out, attention to detail, lead dressing is short. Yeah, it's very, very well made, which sort of leads me to lean towards this being made by a company rather than being built as a kit. But if we look at the back, we've got a load of inputs and outputs. So these labels here, this sort of tape is what you used to get back in the day before we had fancy printers and everything. You just like punch the letter in. It had like a daisy wheel like type thing, and you you punched the labels out like on a bit of tape. So this sort of leads you the other way towards like a homemade sort of device, because you would have thought if this had been a kit, then it would have proper labelling like the front panel. So the back panel is telling us something different to the front panel, because if we look at the, I know it's upside down, if we look at the front panel, this is professionally done screen printing, I would think. The same goes for the paintwork. I mean, this is professionally done paintwork. This isn't the sort of thing you get from a rattle can back in the day, or even like brushing it on. So having mucked about with valves and things for a few years, I'm pretty certain that the circuit is based on the Mullard Stereophonic Preamplifier, 2-valve preamplifier. However, it gets a bit more murky after that. In the 1950s, Mullard released a new series of valves. Prior to like this range being released, most valves were octal, and so they released the EF86, ECC81, 82, 83, EL84, EL34 maybe. And so to promote this new series of valves, they produced a few circuits which you could build at home. One of which is the Mullard 510 amplifier, the 520 amplifier, which use the EF86, ECC83 and EL84 in the 510 version, and the EL34 in the 520 version. They also released the design for the 2-valve preamplifier. Also at this sort of time, you had companies like Stearns Radio, which were based in London, which produced kits using Mullard's circuit, and they would make like a kit, you know, the chassis and everything, and you get it through the post and build it yourself. What would happen is you'd have your Mullard 510, for instance, or a 520 amplifier. The power supply from that would power your preamp, and then probably this here, this output here, which is just basically daisy chained to this plug here, will go to a tuner like a radio, and obviously your inputs would go in the back. Anyway, that's a bit of the back history of what I'm pretty sure is this preamplifier. Next, where do we go from here? So I started basically by buzzing out the circuit, trying to find where the wires from this plug go and all the rest of it, which is pretty simple. We need a ground, we need HT, and we need a heater supply. So that's 4 wires. The red is obviously your HT, your blue is heater, purple is heater, ground, that's just floating about at the moment. So we know how to power it up. So you bought your doodad off eBay, you've done your research, you know which wire goes where and all the rest of it, and you have a pretty good idea of how to power it up and all that. Do you power it straight up? Well, the golden rule is with anything of this era that hasn't been powered up for a long time, no, you don't just like whack a load of volts in there and hope for the best. Why? Because we've got a couple of electrolytic capacitors there, and from just looking at it and everything, they are decoupling capacitors which filter the HT coming in before it goes to the preamplifier to try and reduce ripple. The other thing is with not so much with the preamplifier but with the power amplifier, if we get a leaky capacitor, like a leaky film capacitor, that could put a positive voltage on the grid of a valve and send it into runaway, thermal runaway, and melt it, destroying any output transformer and all the rest of it. That's not the case in this instance. You could take the approach of testing and replacing all the various components and then powering it up. But in this instance, what I'm going to do, I'm going to apply power, but I'm going to current limit it and just monitor the voltage and just see if we get anything out the other end. Before this can be actually used, I need to speak to the owner of the preamplifier and find out what he wants to do, because as it is, it can't be used with, say, a transistor amplifier. It needs a power supply for a start, and all the switches will need cleaning, and like I say, you probably need a few components replaced as well. So rather than just go in and just tear out everything and then replace them, I'm going to power it up first and then take it from there, but just do it in a current limited way. Here we are the next morning, powering it up for the first time. No valves in it, no heater supply connected. All I'm doing is powering it up through this 100 ohm resistor, and essentially what I'm interested in is just reforming these two electrolytic capacitors there. Actually there is 4 capacitors, because these are dual 16 microfarad capacitors. They are double capacitors, and at the moment everything seems to be going very well. I shall point you at the meters. Creak. I think you can see that. So here we've got the reading, the voltage across that 100 ohm capacitor. So if we want to read current off there, we divide that by 100 and we get 2.2 milliamps, which is acceptable, very acceptable for really old capacitors. At the moment we're sitting at 200 volts. So essentially what happens is when the HT comes in from the umbilical, when this is ordinarily connected, it goes through a 15k and then a 3k3 resistor into each of the 16 microfarad capacitors, and they obviously form an RC filter and filter the ripple. So I'm just gonna, if you look at this meter here, I'm actually reading the voltage on the capacitors. This is one side at 185, so we've got a drop of what? 15 volts in it. So yeah, I would expect that to be a bit higher, but you know, they're all capacitors. Like me, like, you know, like us Odins, like when we get out of bed, we're not like firing an old 4 cylinders in the morning. And the other one is 167. And if we pop over the other side, if I can do this without giving myself a belt and shorting anything, I've got 184 and 170. What was the other one? Yeah. So yeah, that's healthy-ish. I'm going to just leave that for, yeah, I don't know, however long it takes. I want to see that come down really. We really want to be seeing that, like, moving a tenth, you know, like one place, decimal point, like into the micro, yeah, that's right, microamp range. Yeah, so we really want to see that like 24 rather than 204. Although, to be honest, probably this is about all we're going to, you know, get at this moment. But anyway, I shall stop waffling, leave that on for a bit, and come back in a little while, see if anything's changed. I suspect not. It's about 40 minutes later. As you can see, the voltage across the 100 ohm resistor has dropped, and we're now reading, well, let's call that 140. So we are going down. Let's just check the voltage. 190, that's going up. Good, good, good. 177. Where's the other one now? Try not to short out. Okay, a little bit lower. 188. 177. Right, so we're heading in the right direction, but it just goes to show you what sort of leakage you get on old electrolytic capacitors, because there's nothing else in this preamplifier that's drawing current. Right, well, some more time has gone, and as you can see, the current across that capacitor is falling. Just whacking it up to 300 volts, which is the working voltage of the preamplifier, 300 volts HT, and that's not bad. Just have a look at the capacitors one last time. 283, 258, 279. Oops, you bugger. Really got to watch slipping with a fucking probe. One slip and bang. Right, there we go. That's cushy. Looking at this figure here, and I'm also feeling the cans of the capacitors with my finger to see if they're getting hot. If they're getting hot, obviously, you know, they might start to go bang at some point, but they're not getting hot. They're lovely and cool. So I'm going to knock the voltage down from my main supply, stick some valves in, apply some heater voltage, and see what the crack is. I've discharged the capacitors. These are the two caps I was reforming, and one thing I'm going to do before I power it up is get rid of this umbilical. I'm pretty sure that Ian's brother won't be using it, basically because he's got no to plug it into yet. So at some point, obviously, I'm going to have to probably build a power supply, but it's a really thick cable. I mean, it's very good quality cable. Can probably use it later, but however, in its design, it is not really brilliant, because we've got, where are we? You can't fucking see, can you? It's not really how it's, the power supplies that go through it doesn't make this ideal. For a start, we've got down the bottom here, this is a mains switch, so basically that main switch would switch a power supply which is somewhere else, or the amplifier, on, thus powering this up. So you've got 250 volts AC going through there, as well as your 300 volts DC, and you've also got obviously 6.3 volts, probably only at a few amps, but you know, that's gonna couple capacitively into your HT, and obviously onto the grids, well, onto the anodes, etc., of the valves. So yeah, not a brilliant design. So we're going to get rid of that, and then it'll be able to handle the thing a lot easier. Before we power it up, with the help of my friends on the Vintage UK Radio Restoration Forum, we positively ID'd the preamplifier as a Stearns I've been called it Fetic Stereophonic dual channel 2-stage preamplifier. The Stearns presentation of a Mullard design, as I mentioned, stereophonic and dual channel monaural facilities, 5 separate inputs, continuously variable separate bass and treble controls, simple, easy to follow instructions. And this is dated, if I am right, at 1963, and this booklet will cost you 3 shillings. I'm sure 3 shillings wasn't the price of the kit. It then goes into great detail about the design and all the rest of it. If we, am I tripping? No, here we go. This is the bit I'm after, and I will try and blow this up a bit. Kill that over there. No, I can't go, can we? There we go. Why can't I go down? Fuck's sake. There we go. Right, so as you can see, this shows you how to connect it up to your power amplifiers. So one power amplifier that I didn't mention was the excellent Mullard 3.3 power amplifier, so, or the Stearns version of it. So basically the preamplifier would be powered from your power amplifier, and then you would put the outputs from that into your power amplifier. And where are we? On part 2, and this is the schematic. So as you can see, it looks pretty busy, but a lot of this is attenuation or tone shaping of the inputs. So I would think this is auxiliary radio tuner, what was it, auxiliary radio tuner, magnetic crystal, maybe something like that. That goes into your first valve there, blah de blah de blah. Then you got a load of blah 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 tone controls after the second EF86. One thing what I'm not seeing here, which I don't know whether it'll be a factor or not, is a cathode follower to drive the signal to your power amplifier. I mean, whether the capacitance of the lead from this preamplifier to the power amplifier would be an issue, I don't know. Anyway, we'll go into the actual circuit later. Let's go and power it up. So there's the DUT, the device on the test on the bench. I've already filmed this bloody once, but forgot to press record. It's upside down so we can get that, so I can get access to the valve bases, so I can take some DC conditions. Squeak. Remove the split pin tub there. This small bench supply is powering the heaters. Squeak. And this big one here is supplying the HT. I've got 2 meters. This one is reading the HT going in to the preamplifier, and this one I shall be using to check the DC conditions. The Stearns booklet that I just showed you, while it's really detailed, it doesn't give you any voltages, so we're just sort of winging it really. I'm pretty sure the Mullard, original Mullard schematic doesn't give you any voltages either, although I might be wrong. So as always, I start with any device, or whether it's an amplifier I built myself, by checking the DC conditions. Really the main parameter we need to check to see if the thing is working, at least in the DC wise, is the cathode. If you've got no voltage on the cathode, then the valve isn't pulling any current. So I've just basically got HT1, which is the HT going in. These are on those 2 capacitors that are reformed earlier, and I've got a anode, grid 1 cathode, grid 2, etc. Right, I'll go and do that off camera because it's a bit boring, and then we'll see what we shall see. So we've got some anomalous readings. These are this is the HT going in, 300 volts, 252 on that first capacitor, 250, 216, 213, everything's cushy so far. V1 anode, 105, 32, straight away there's something wrong there. Grid 1 reading, 0.2, 0.4, yeah, not bad. Cathode as mentioned, that's your important one, 1.2 volts, bugger all on the second one, and I don't think it's me probe not making contact. Screen grid G2, 8746, so something wrong here. This is very low again, 30, and then we've got like this sort of reading here, 2.1, 2.1, that's on the control grid and cathode. Needs a look at. G2 screen grid, 22 volts. Over here, this is looking a bit more normal. Anode 60 volts. Control grid less than a volt. Cathode 1.5. Yep, so that one that needs a look at. So that's pretty much what I expected really, for saying this probably hasn't been powered up for decades or whatever. For a start, what I would do now, probably yes, clean the valve bases up and everything, but really this is where the work starts now. For instance, these resistors here are high stability types, they're probably absolutely fine. Some of the electrolytics, smaller electrolytics, which are cathode decoupling capacitors, may need a look at. These big mica mold debilier, I'm pretty sure they're debilier mica molds, they'll have to go and want changing. If they're not buggered now, they probably will be buggered at some point in the future. These two resistors here look okay. Probably, I don't know, maybe an old carbon comp, maybe not. The resistors really that do need checking are these carbon comps here, which looks like 100k, 100k. And the resistors, these are airy ceramic resistors. Basically it's a ceramic tube and there's a carbon comp resistor in that tube. They're known for going over resistance, so going high in voltage. However, the readings we were getting on the capacitors, they're probably alright, but we don't know. As you can see, there has probably been some changes in the past. Let me just move that out of the way. So that one might be original, I don't know, but they'll need a look at. So that's the DC side of it. If we can get that right, then the next tricky bit is actually the AC side. Let me just turn my big bench supply off. So yeah, going forward, the AC side. These are very stable Sufflex polystyrene capacitors, probably absolutely fine, but they are known sometimes for going, I don't know, leaky or just whatever. Couple more Sufflex down there, although it looks like one has been changed at some point in the past, or maybe that was just what the chap used. If you look here as well, got a couple of carbon comps, 47k, may need looking at. What's that one? That is a 39k. Same capacitors, resistors, capacitors, I'm not quite sure what they are. They're probably some sort of film type capacitor. Obviously needs sorting. The potentiometers probably will need a good clean. These resistors here look like precision. I don't know if they're panclimactic types, but they're probably okay. They just form the attenuation of the signals going in. This is our input here, but there are some carbon comps down there, and I don't know if you can see down there are some waxy caps as well. I mean, they probably will need replacing. However, like, getting at the thing is less than straightforward. To get proper, really good access, I mean, the thing wants taken apart, but that, stop trying to jig this about so much, but that maybe would involve, I don't know, I'll come to that when I get down, when I get to that point. And then depending on what Ian's brother wants to do with it, we need to build a, well, I need to build a power supply, probably, yeah. So a lot of work going forward. I do have, una memento, I do have this old transformer here, which is the Gresham, which is probably contemporary with this beastie, although it looks an absolute monster and is massive and all the rest of it. It can probably only, I'm pretty sure it can only do, yeah, 6, that's not right. I'm pretty sure it can only, yeah, it's suitable for a preamp. Yeah, pretty damn sure. And that came out of an old bit of kit. These again, W capacitors, but these are paper in oil, which were part of that power supply. I doubt I will ever use these for anything, so these are probable candidates, as well as this Partridge 75mm 10 Henry 125 ohm choke. That would make a nice power supply. However, all of that lot is about as big as the thing again. So yeah, I'll have to have a chat with the owner of the preamp and see where we're going with that, because I can make that a hell of a lot smaller without all that. Again, yeah, it's up to him, but it is sort of period correct. We'll see. So I think this video is probably long enough, and so we'll call this part 1, and I shall see you in part 2. Thank you all very much for watching. Take care of yourselves. Ta-da for now.